Number 8. It says an industrial power plant uses a step-up transformer to step up the voltage of the signal by a factor of 30. Suggest a possible turn ratio in the primary and secondary coils to achieve this. So it is basically saying, so because it's a step-up transformer, it means your primary is going to be smaller than your secondary. And this is saying that it's got to be a factor of 30. So if you think of it as a ratio, the difference has got to be a factor of 30. And because it's a step up transformer, it means you'd have to have a ratio of 1 to 30. So this is basically saying suggest a possible turn ratio in the primary and secondary coil. So if you had to step the number up by a factor, then your ratio would be 1 to 30, which is good enough because if you had 1 volt on one side, you would have 30 volts on the other, similar to question 1A, where your number of turns actually matches the ratio. It could be you could have a value that's not the same as your ratio. So whatever it is, as long as the ratio stays the same. So for instance, if you multiplied each side by 2, the ratio stays the same. So you could have 2 on one side and 60 on the other. Because when you work the ratio out of that, it goes back to 1 to 30 ratio. So it's any multiples of that: 1 to 30, 2 to 60, 3 to 90. Because again, if you had a ratio of 3 to 90, if you divided both sides by 3, you would get 1 on one side and you would have 30 on the other. So your ratio would stay the same with any of those combinations. So if you multiply one side by a number and you multiply the other side by the number, the ratio of 1 to 30 stays the same. Or if it's a different ratio, it'll still be the same. Number 9. It says a young boy's train set is designed to operate safely at 20 volts. A transformer has the capability of stepping mains voltage down to this value. So we are going from mains voltage down to 20 volts. Now, in this question, mains voltage is assumed at 230 volts. So if it says mains voltage, or in another question, UK mains voltage, you need to use 230 volts. So in this example, it's saying the train set is designed to operate safely at 20 volts. The transformer has the capability of stepping mains voltage down to this value. So already we know that voltage primary is 230. Secondary, so what's going to the is 20. So we already know those. Count 115 turns in the primary. So number of turns, N, in the primary is 115. So it just then becomes exactly the same workings. as before. So we've got a voltage on either side, primary, secondary voltage, 230 on the primary, 20 on the secondary. Ratio 230 divided by 20 is 11.5. So the ratio is 11.5 to 1. We know that the primary number of coils is 115. So we know that anything on this side is 11.5 times greater than the other. So we need to take the 115 and divide it by 11.5. So 115 divided by 11.5, 10. So the ratios are the same. It's 11.5 to 1 or 115 to 10. So if you divided either side by 10, you would still get 11.5 to 1. So just draw it out, draw it that way, map it out, find your ratio. It doesn't matter whether it's your voltage or your number of turns first. If you do it big by small and then put your lowest number column is your 1 and your ratio is for your larger number, follow it that way. It doesn't matter which way it is, you should hopefully be able to follow it. Number 10. So Auntie in America sends a mega frying pan as a wedding gift. So the frying pan is designed to operate at 115 volts. So UK voltage is 230 volts. America is 115. So they're basically implying she's got an appliance from America and it's in the UK. Suggest a possible turn ratio for the transformer if the pan is to be operated safely at British mains voltage. So working on mentioned in the previous question about mains voltage. So for British mains voltage, we will assume 230 volts. And it's saying that the appliance needs to be 115 volts. So it's taking primary is taking in 230 volts. Your secondary is giving out 115 volts. So with this question, it's not actually interested in it. It wants to know what the ratio is. And we've been using that ratio all the time to calculate the number of turns. So in this question, we've got the voltage primary and secondary, and that's all it's bothered about. So again, primary, secondary, voltage. Primary is 230, secondary is 115. 230 divided by 115. 2. So your ratio, hopefully you can see, is 2 to 1. So that question is just purely asking about the ratio. It's not bothered about the number of turns because it hasn't given you a value for the number of turns. It's purely interested in the ratio. So for this equation, 2 lots of 115 going to 230. So the ratio is 2 to 1.